Hi and welcome to another Technology Tuesday. Today we're going to be talking about compression and in particular compression of the Storwize V7000. So first up we'll take a wee look at other Technology Tuesdays that we've got coming along. So here's the schedule to take us up to March. So as you see, the first Tuesday of every month we'll be running a couple of seminars, roughly one on hardware and one on software. So later on today we will have the VMware Security with Trend Micro. Actually, it's not Tuesday today, this is getting pre-recorded. I'm off on Tuesday, so we'll play this back at the Tuesday webinar, and hopefully the guys taking the webinar will be able to handle any questions you've got. If not, feel free to email them to me later on. So we're going to be looking at primary data compression. I was going to look at backup data compression as well, but we're a bit short on time, so we'll probably just stick to the primary data just now. Maybe do another session later on for backup data. So what is my definition of primary data? Because everybody's got it slightly different. Well, for me, it's the storage of your live data. It's typically the most expensive storage that you've got, and typically you demand the most performance of it. So you can kind of see why we would want to compress it, because we'd get more bang for a buck or punch for a pound. It's the most expensive thing, it's the most performant, so we want to get more on it. So we're going to take a quick wee look at compression algorithm. So we use LZ lossless, which is pretty much the standard for everything. Okay, so every manufacturer out there really uses LZ lossless. It's been around since 1970. It actually, so it's called lossless because it doesn't actually lose any data. It's compressed using statistical redundancy to get rid of bits that are repeated. So it's standard out there. Things like WinZip, and as I say, pretty much every manufacturer uses this compression algorithm. What's different is the way that it's implemented. Okay, so if we look at how pretty much everybody else implements LZ lossless, if we take this example here, we've got 100K change to a 1 megabyte compressed block. What is it that would need to be done? Well, first up, you need to read that 1 megabyte block out of the storage system. You then need to decompress that 1 meg block. You need to make that 100K change, and then compress that 1 meg block back using the LZ compression algorithm, and then write that 1 meg block. So as you can see, there's lots of read and writes going on there, lots of operations, and this is why for the majority of manufacturers they say, yeah, you can put compression on and our storage system handles compression, but you know, you're going to take a performance hit. So it's usually you've got to weigh up between compression and performance, and that's why they don't recommend that you put compression on your live data or your most important performant data. So if we take a quick look now at how the Storwize V7000 does its compression. So as I say, it's the same compression algorithm, okay, so no data being lost. And for them to make this 100K change to a 1 megabyte block, they compress the 100K using the LZ, and they update the 100K. And that's pretty much it, okay, so much smaller and much less operations going on there. So if you look at the Storwize product, they've actually got about 35 patents. None of them are around compression. It's all about real time, about how they do this this write and this update. So it's the same compression as everybody else's. It's standard, it's reliable, and they're just going to do it real time. So that's the key for them. So because it takes very little additional overhead, you can put this onto your production data. So I'm going to quickly talk about some other sort of things around there as well. So not compression, but deduplication. So you might have heard of deduplication. Typically this is on NetApp products, and it's come off a whole lot of other things as well. So what deduplication does is it writes the data to the disk in the first place, and then on a scheduled job, it goes through all the data that it's stored, and if it sees a duplicate block, what it does is it just keeps one copy of that block, and it maintains a pointer. So it's got, like, say, 2 pointers and one block. So there's a couple of problems with this. One is obviously you've got to write the data in the first place. The second is what happens if you've got a very busy system and you may be running 24/7, or you've got additional batch jobs at night and you don't have time to run this quite intensive job of deduplication. And the third one is obviously the database of pointers. If that becomes corrupt, then that's quite an issue. But so fundamentally, deduplication and compression are different things. We can run compression on deduplication. Okay, so if you've got a deduplication system, you can run compression alongside it. And we'll show you a little bit of what that might look like. So deduplication, then, you've got, say, a fat block and a fat block. Then you're going to run deduplication and you're going to keep one fat block, effectively. If we look at compression, what you've got is you've got a fat block which is compressed into thin, a fat block which is compressed into thin, and you end up holding 2 times thin blocks. With compression and deduplication, you have your fat which you compress to thin, your fat which you compress to thin, you then dedupe it, and you only hold a single thin. Okay, so these technologies can be stacked on top of each other, and you can get some compression benefits even if you're running deduplication. So the product that has this compression is called the IBM Storwize V7000. That's pretty much what you would consider as a sort of standard storage device. So it comes in a SAN or a NAS solution. Out the box, it's sort of like a 2U 24 disk 2 controller system. It runs some storage virtualization and external virtualization. So what that means is you've kind of decoupled the data from the disk, so you can move it around a bit more. It's not tied to that particular disk like old-fashioned RAID arrays. And because of that, you can do this external virtualization, which means your existing storage, you can put a Storwize V7 in front of it, and it can manage it, and it can give it all the functionality that it has. Easy tier is one of the functionalities that we talked about last month. This is the ability to be able to move data around dependent on its access frequency. So things that are accessed the most often are moved up to SSDs, and things that are least accessed are moved down to slower disks. Real-time compression, which we're talking about today, so we've kind of gone over that. It's the way that it does the updates more than anything else. And this means that we can use it for primary data. Okay, so your VMware, your SQL Server, your Oracles, and things like that. There's no overhead for switching this on, so you get the benefits without the performance. A couple of points at the bottom here. We've got. Just wanted to say it's like it's version 7 of the software, so it's been around for a while. It's nice and stable. Hardware on generation 2 as well. The generation 2 hardware was really around compression, so it's got more CPUs and it's got dedicated compression cards. So actually, Gen 2 running compression runs faster than Gen 1 without compression. And my last point there, you can get up to 5 times space saving with compression with no performance hit. Okay, it's a no performance hit, which is quite important there. In fact, IBM has a compression guarantee. So if my slide decides to change, good, thank you very much. 50% saving on disk is what they're saying. So we've seen 75–80% savings, but they're guaranteeing, IBM are guaranteeing a 50% saving on disk space. So what does that mean to you? It means, well, you either need to buy 50% less disk, or my preference would be that you buy the same amount of disks, so I get a bigger order, But then you don't have to go back to the business 12 months time and go, oh, excuse me, can I get some more storage? It's this 50% saving, as I say, we've seen like 75-80% saving as well. To give you a real world example of that, I've seen 42U rack of storage being replaced by 6U of a V7000. So when you think about the power savings, the hosting savings, the management savings and things like that, it's really good. So just to prove to you that I didn't make up the compression guarantee thing, this is an extract from the legal documents from IBM, which we would fill in on your behalf. And it's basically stating that if you don't get the compression and the performance, okay, so this is about compression and performance that they've stated you would, then they would put additional hardware on the ground to make sure that that performance and capacity works. So to do that, you would need to engage with your local friendly VAR, say Seric Systems. We can get all this set up for you. There's a couple of tools which they need to run on your data to understand it, and they'll do their calculations on that. And we'll do some modeling as well. So we've got some disk modeling software, so we'll kind of come up with the configuration which is required. They'll validate that, and then they'll put this in place. So it's quite a strong statement. I've never really seen a manufacturer saying something like that before. One of the tools that they use to work out what data you've got is called the comprestimator. As I said, this runs on your data and it estimates your compression savings. It's a command line tool. It runs in just a couple of seconds, so it doesn't chunter away forever and check all your data, so it can be run at any time. And it's 97% accurate. As I say, they base their guarantee on that. So there's a URL there if you want to go and get a look at the comprestimator yourself. But I would recommend probably engaging with us, and we can help get those stats back on in, model your solution, and then get all that signed off for you. So I'm going to finish with a video here. Hopefully, videos never seem to work very well in PowerPoint for me. This is a quick recap from Ed Walsh, who works for IBM. Probably going to say everything much more succinctly than I've just said it. But Ed Walsh, if you haven't heard about him, he's big in the storage world. He was the brains behind Avamar, which EMC bought for a lot of money. He then joined Storwize, which IBM bought for a lot of money. So he's got a lot of brains and he's got a lot of money.
All right, so at the risk of getting one of those, you see, one of those little grins, at the risk I want to talk about real-time data compression.
Okay, sure.
We hear about it.
Yeah.
Previous lives you've talked about it. At
sure.
IBM you're talking about it. How the heck, so imagine I'm not an analyst anymore, I'm now a user.
Yeah.
Why, well, I think I know why I care, but I'm also really worried this is going to just kill my performance. Make me feel good.
I've never heard about that.
I bet you haven't.
So, people understand real-time compression, especially with the word compression in it, and I get to save a lot of capacity. And people understand data sets 2x is fairly straightforward, but it can get 3, 4, up to 5x capacity. They get that out of the gate. The real key is how does it not kill their performance in their environment. But we went to the exact same scenario when we did data dedupe. You have to walk clients through a couple questions. They naturally say, I get the value, but can you explain more? The first question is, what are you doing with my data? How are you compressing that? How do I get my data back? How does that work so I can understand it? But then the next question that's always put in form of a statement, if you would, is, no way that can be fast. And then we have to go away to educate in those two pieces and really prove it out to people. But when it takes off and you have it integrated, it really takes off. We saw that in tape compression, we saw it in WAN optimization, we saw it in data dedupe, and now we're seeing on primary real-time compression. So to answer your question specifically, but let's answer them. What are you doing with my data? I'm doing LZ compression. Now that's lossless and deterministic both in performance and also capacity ratios. The next thing is it's real-time, and what we mean by that is actually there's a lot of technology behind it. So just like when we're talking about dedupe, we had to explain a lot of technology, and we finally simplified and said we dedupe it, we'll come back to it, we'll explain the technology. But what real-time compression does is basically fundamentally different than what the other guys are doing. So everyone in the industry is using standard LZ compression like us, but this would be all the different competitors, right? And what they do is simple. They take a particular volume, they compress it, and they put it on disk. That's where all the similarities just completely disappear from there. So let's do a couple IOs. So we're talking about your active data. So you're going to be able to do real-time compression on things like Oracle, DB2, VMware, VDI environments. Your active data, what you have in your data set.
And I'll just go slower, yeah?
So the key thing is what you have is now you have data on this on the disk itself. You know, it's being compressed, and that I/O comes down. So let's say you've got 1 meg file sitting on disk now that's been compressed, and let's say a 100K update comes. Now remember, I'm going to show you one update, but let's say in a database it's thousands or tens of thousands of IOPS per second, but I'm going to do one. To modify a 100K modification, you literally have to take that 1 meg file you compressed, read it into memory, decompress it, modify it, recompress it, and put it back out to storage. Now you might keep some of that memory, but for consistency you're going to go out to storage. So here's the difference between that and real-time compression. So we do the same thing. We use LC compression, we compress your file, we put it out on storage. But now this modification comes, 100K. What we're able to do is first compress it.
Compress the modification, okay, or the data that is the modifier.
And then we update the file. We don't have to decompress or read that file to operate on it. We can operate on the compressed data. So one more time. Take 100K, first compress it, you update the file. Now you can do that very fast. The difference between those two is huge. So on the first example, how traditional compression works is to do a 100K update. I know I did it quick, but you have to do an order of magnitude more I/O, 1 meg read, forget about opening and closing it, and among a 1 meg write. That's an order of magnitude times 2 IOs to do 100K.
Right.
Where real-time compression, believe it or not, we're compressing it then writing it. So it's actually stressing the hard disk drive even less, which is the slowest part of the overall infrastructure.
Yep.
So one, the difference between the two is a lot of technology, about 35 different patents, but one you can make real-time. And we'll show benchmarks with VMware, Oracle databases, VDI, DB2, and you actually see cut your storage in half, and there's no performance or application degradation. Sometimes you actually see some performance increases. Edge cases, you could see it even, but in general, no performance degradation. But with the other technology, there's just no way. So when you ask the questions of what are you doing with my data, actually fairly similar.
Well, so the answer is you're not really doing anything that I should be worried about.
Right.
That's the quick answer.
But then the next question for us and the competitors is, well, there's no way that's going to be fast. And with the other competitor, you're absolutely right. There's no way it's going to be fast. In fact, they tell you that. But yeah, be careful what you. Yeah, if you have to get that.
Yeah.
back,
What would you like? So the choice with others is what would you like? Performance or compression?
Right, and if
Almost.
you have to uncompress it, it can hurt the performance of the overall subsystem. So buyer beware. With ours, to say, no, you can compress. In fact, we've made it for active data. That's something that changes. So if you look at all the other paradigms, tape compression, WAN compression, data dedupe, and now primary, what are you doing with that data? It's pretty straightforward. You know, no way that can be fast. Once you prove that, you make it simple and integrated. Ours is a software key that you turn on to our different fiber channel-based subsystems. Make it very simple, and the market takes off. People get huge value, and that's really the difference between real-time compression and everyone else out there.
So very succinct. It's good. You can watch that on YouTube if you want. There's lots of other stuff out there on YouTube as well, along with our own channel, Seric Video. So sign up to that, and don't forget Seric Can Help and Technology Tuesdays, first Tuesday of every month. Thank you very much.